Okay, now time for the other plot we're supposed to make. And the other plot's going to be, make a second graph, t period squared on the y-axis, L on the x-axis, and in theory, according to the theory, the slope ought to be equal to 4 pi squared over g. Okay, so that's pretty straightforward. So I came up with a, well, first of all, we got to make a t squared. So that's pretty easy, right? Because just square it. Nothing to it, right? Everything else is the same from before. And then to get plus minus t squared, well, I got to go back to my table of error propagation. And if you think about it for a minute, t squared equals t times t. So that's this one. So, and as always, sigma a b equals 0. So if I want plus or minus t squared, I multiply the t squared times plus minus t over t squared, right? Just like that. And then plus minus t over t squared again, because it's the same two things. Then notice that becomes 2 times. If I take the square root, I get t squared plus square root of 2 times plus minus t over t. Now, don't do something like canceling these two things out, right? Because this is t squared and t, it's not, well, I suppose you could when I think about it, but I've run into trouble personally when I've done that in the past, so I would say you probably don't want to mess with that, right? Okay, so let's just clean things up a little bit here before we move on. I'm going to pause. Time to resume. All right, what do we got now? Oh yeah, so let's put that into reality. And I suppose I could go use the convention we've been using. What's going on? And I could be putting units in here. Just because I don't put units in when I make these videos, that doesn't give you license that you don't have to put that in stuff that you submit. We're not in high school anymore. Okay. So now I've set up my fit line. And in fact, then I got a little redundancy here. So delete this and shift cells left. And I suppose we want to move this over just to make it look a little cleaner. There we go. Let's see, something, ref, huh? Okay, so the data minus the fit. Oh, it's not going to get it, huh? Well, I'll just change that to an L. And then I want to close it and square it. And it's wrong. Oh, of course, it's K18. And that's this. Okay. Nice. And this equals the residual square divided by the error bar squared, which is this. And once again, oops, we have to do something about that. Home number, and that should be okay. So we see just as to pass the, oh, this one's a little different. Well, that's okay because, you know, what this has to do with whoever has the largest error bar. In fact, the smallest error bar. Interesting. So when I do log, it's this one that's the smallest error bar, but oh, interesting. Okay. So let's get ourselves our borders going on. And now we need, well, we can just do, we have to retype it, right? In fact, let's see, maybe some trick I learned, I don't know if it was with you guys. Now if I paste that, right? So now, what's the, oh, it worked. I don't know. That's dumb luck. Well, because it matches the pattern. But if it didn't, man, I've learned that you can just move the border around of this box. Nice, we're in, huh? Okay, so let's see now. Now we want to plot things that aren't next to each other and non-contiguous. So first you select your L's, then you hold down the control key, and now you have your t squared, period squared. Insert, and we want a scatter plot. Well, that looks nice and linear, doesn't it, huh? And so let's insert to there, error bar. And let's see, without using the bar on the right, because our Mac users won't have it. So there's the X error bar. Oh, interesting. Is there any ways of manipulating it? No, we have to have that gray bar on the right. There's no way around it. Okay. Interesting. Okay. But we can still select it from the format menu. Yep. And so we want them to be 0. And we need to format the Y error bars. And so that is the plus minus t squared. And the plus minus t squared again. And so we have something similar, and the error bars are a lot smaller now. But we also notice that the variation of data is smaller too. All right, now we want to add the fit line. Select, add, and that's the t squared fit line. And the x values are the lengths. And the y values are the t squared. Oh no, the fit line. Yeah. Nice. Okay. Now format, and we want to format the fit line. And again, we like our solid line. And I want to eliminate the marker. Far out. Right? Okay. So obviously that could be better. So we once again go to our solver. And we say, all right, we want to minimize a new chi-square. And now we want to change the two parameters because now I want those. And we say solve. And it's always a good idea because you say okay, you can't hit the back button. All right, look at that, huh? And yes, once again, That one point, it's kind of an outlier, is right out there, but I wouldn't. I'm not sweating over it because I can't remember just how good this data is. But the variation, the dots back and forth across the fit line is right away when you look at data. That's you can see that. I would say the people who put error bars on this data, they didn't make them big enough, right? Because I can right away see the variation. And this is, because we kind of just did a really arbitrary thing with the period. Oh yeah, of course, I just realized you can certainly add quite a bit more of the error to the error because we're only thinking about pressing the button. How about judging when it's actually an integral number of when if it's 1, 2, 3, 4, 5 periods. So that's certainly I bet it's adding at least a half a second, if not more. Well, so we could certainly probably at least add a half a second to each one of these. Let's see what happens. I'm interested in that. So this becomes what? 0.7, 0.8, 0.6, 0.55, 0.75. Yeah, so, that becomes much more believable. And, in fact, let's do a fit again. So I would bet it's going to change a little bit. Let's see. Solve. And yeah, it definitely looks like it changed a little bit. Let's see. Restore original. Keep. Let's. Look at that. I want to just copy. And I want to paste the values. Oof. I don't know why the default is general. Okay. So let's hit the solver one more time. I'm interested. We say solve. And yeah. That's interesting. And it goes to 0, which is what we actually would have suspected. Oh. I like it. Okay. So I'll leave this to you guys. So this is the next part. I'm going to stop this and upload it.